Hello, everyone. My name is Karthik Vijayaraghavan, and I'm a DocumentDB Specialist Solutions Architect with AWS. In today's webinar, I'll be talking about Amazon DocumentDB global clusters. So here is a table of contents for today's session. I'll start with what is Amazon DocumentDB, and then give a brief overview about the DocumentDB architecture, and then introduce you to global clusters and talk about global clusters use cases, and also show you demos along the way. So let's get started. What is Amazon DocumentDB? Amazon DocumentDB is a fully managed, scalable, and MongoDB-compatible database service. Let's double-click on what this means. Fully managed. Amazon DocumentDB is fully managed by AWS for you. There is no hardware for you to provision. It's pretty easy to set up through the console or even through CLIs, SDKs, and you can spin up a cluster within minutes time. DocumentDB has built-in high availability, so you can provision your clusters, and all that provisioning is automatic, and the clusters are provisioned across multiple availability zones for you. The best practices are enabled by default. For example, backups are enabled. As a matter of fact, you can disable backups. We give you 1 day of backup by default, and we don't charge you for the initial load of data. And also durability, right? So the data is copied 6 ways across 3 availability zones, regardless of how many instance or what sized instance you have in DocumentDB. Security best practices, likewise, are enabled. You can use IAM authentication for creating DocumentDB resources, like creating a cluster, creating instances within a cluster, and you can leverage the built-in role-based access control to enforce least privileged access. And DocumentDB being a fully managed service, patching and maintenance is handled automatically by the service. Again, this is a native AWS service, and hence, DocumentDB provides out-of-the-box integration with CloudWatch for monitoring and setting up alarms, and with other services like CloudTrail, for example, for logging and auditing, with Secrets Manager to retrieve credentials and rotate credentials, with Key Management Service for encryption of data at rest, and so on. This will help you to simplify your tech stacks in a pretty significant way. And one of our customers, FINRA, they use DocumentDB without any overhead from their engineering team. So that is, again, the benefit that fully managed service brings to the table. DocumentDB is scalable, and this predominantly comes from the services architecture, where the storage and compute are decoupled. Separation of compute and storage allows you to scale both of these independently. You can scale compute horizontally or vertically within minutes, and this is regardless of the amount of storage in the cluster. Also, when it comes to storage and I/O, they auto-scale for you, right? They scale from 10 gigabytes all the way up to 64 terabytes, and our customers like you do not have to worry about provisioning EBS volumes or scaling on-prem storage area networks, or worrying about expensive SSDs and so on. DocumentDB's compute, which are basically the instances, they scale out to 15 read replicas within minutes. So 15 is the maximum number of read replicas you can have within a cluster, and that scaling happens within minutes regardless of your storage volume. Ion is one of our customers that scales their clusters in minutes regardless of their data size, and there are many more that do this. And finally, MongoDB compatibility. DocumentDB is compatible with MongoDB 3.6 and 4.0. And what this means is you can use the same MongoDB SDKs, tools, and application to interact with DocumentDB. DocumentDB supports hundreds of MongoDB APIs, operators, and aggregation stages. And we work backwards from our customers, where our approach historically has been, we start with our customers' need, get feedback from our customers on the product, and feed that feedback back to our engineering teams to implement feature requests. Freshworks is one of our customers that love the fact that we are compatible with MongoDB, Their application required 0 code changes when they migrated to DocumentDB. So let's talk about Amazon DocumentDB architecture now. DocumentDB emulates MongoDB replica set behavior. By MongoDB compatibility, we mean that you will be able to get the same response as you would from a MongoDB cluster for a given query when you're interacting with DocumentDB. DocumentDB is architected to separate storage and compute so that they can be scaled independently. And this architecture allows us to offload the tasks to respective layers. To maintain high durability, DocumentDB replicates data 6 ways across 3 availability zones. And this replication task is offloaded to the storage layer so that your instance resources or compute resources can be freed up to perform compute-heavy work such as query processing. Backup is another task that is offloaded to the storage layer, further freeing up your instances to perform compute-heavy work. Now let's talk about global clusters. Amazon DocumentDB global clusters allows you to replicate data to up to 5 secondary AWS regions. Replication is offloaded to the storage layer, just like how you saw in a single region cluster. Replication is offloaded to the storage layer. Even in multi-region cluster or within the global clusters, replication is offloaded to the storage layer. And this replication is a physical replication from the storage layer in the primary cluster to the storage layer of the secondary clusters. And hence the replica lag is low. It's typically less than a second. Global clusters allows you to recover quickly from regional outages. If and when they happen, should they happen, right? If an AWS region goes down, you can promote a cluster in a secondary region to a standalone cluster that can accept writes. This process typically takes less than a minute and is ideal for applications with strict recovery time objective or RTO requirements. Global clusters are compatible with DocumentDB engine version 4.0. So if you are running on a lower version like 3.6, you will have to upgrade to the new engine version to use global clusters. And if you deploy global clusters, let's say to the maximum 5 secondary AWS regions, in this scenario, the maximum number of reader instances you can run across all the 5 secondary AWS region and the 1 primary region is 90. So that's a pretty big number, which will allow you to scale your reads globally. As you can see in the slide, application 1 writes data to the primary region in the global cluster, and application 2 reads this data in the secondary region. So you can have another application 3 on top of Oregon to read the data from that region. So this makes it ideal for those data locality use cases, and I'll cover more about that just in a bit here. So now that we have seen what global clusters is, let's take a look at a demo. I'll show you how you can create global clusters and then review this setup. So I'm here at the DocumentDB console, and I have 2 clusters here. I have pre-created a global cluster, and I also have a regional cluster, which is the standard cluster that you create in DocumentDB. So by default, when you create a cluster, it takes the role of a regional cluster. And what I'm going to do is I'm going to show you how you can convert this regional cluster into a global cluster and then walk you through it. So this regional cluster has like 1 primary instance and 2 replica instances of size R5 large. And what I'm going to do now is to this regional cluster, I'm going to add a region and convert it into a global cluster. So I select the regional cluster, and then I come over here and say add region. And right now I'm in the Ohio region, and I'm going to add my secondary region to be Frankfurt. And I'm going to give this global cluster an identifier. Let's call this a demo. And I'm going to give the secondary cluster, which is the cluster that will be created in Frankfurt, another identifier. So this is the cluster in Frankfurt. I'm going to call this as region 2 cluster, and I'll leave the instance class as R5 large. I don't have to match the number of instances, in different clusters within a global cluster. So in this case, I can just say, I just want one instance, and you can always scale it out when you need it, or even scale it up if you want to. So with that, I'm going to go and say create cluster. So this process is going to create a secondary cluster called region 2 in the Frankfurt region. And if you pay attention to the UI here, you can see that we now have a global cluster, which is called demo. This was the global cluster identifier we provided. And the region 1 cluster, which I pre-created, is now taking the role of a primary cluster inside this global cluster. And then the region 2 cluster has a role of secondary cluster, and it is in creating status, and the primary cluster is in modifying status, so that whenever the secondary cluster is ready, the primary cluster will start replicating data to the secondary cluster. So this process would take about 8 to 10 minutes to create. So in the meantime, I'm also going to show you how you can add more regions. Like I said before, you can have up to 5 secondary AWS regions. So let's see how you can add the second region here, or the second secondary region in this cluster. So for this, now I'm going to select the global cluster. Earlier, I selected the regional cluster, but now that since the regional cluster is converted into a primary cluster and we have a global cluster, I'm selecting the global cluster and saying add region. And this time, I'm going to replicate the data further east. So I'm going to select APAC Mumbai as my secondary region. And I don't have to give a global cluster identifier because I'm selecting the global cluster demo. So it automatically adds this region to that cluster. And I'm going to give a cluster identifier for the secondary cluster in the Mumbai region. So let's call this as region 3. And here again, I can have 1, 2, or up to 16 instances. I'm just going to say 2. And there's no particular reason. I'm just showing you that you can run different sized instances across the regions. I'm going to say create again. So this will create the secondary cluster in the APAC Mumbai region, and it'll create it as a part of this global cluster demo. So as you can see here, the region 3 cluster we just created is also in creating status, and it is also a part of the global cluster called demo. So since this process is going to take about 8 to 10 minutes to create, I have pre-created a cluster with similar configuration here. It's called global cluster demo. And as you can see, it also has the role of global cluster version 4. It also has exact same regions. The clusters are having a different identifier for obvious reasons. So here I have a cluster, again, in the same US East 2 or Ohio region. My secondary one is in EU Central 1, which is Frankfurt. And my another secondary cluster is in AP South 1, which is Mumbai. So you can see that this cluster has 3 instances. This cluster has 1 instance. And my Frankfurt cluster has 2 instances in this case. So what I'm going to do now is show you, the cluster configuration for each of these. So if I click on this cluster, primary region, which is in Ohio, you can access the cluster just like how you can access any regular DocumentDB cluster. So you can see that this cluster has a, under the connectivity and security tab, has the connection string to connect to DocumentDB. So you can copy this and connect to DocumentDB. Now, pay attention to this cluster endpoint. It is like very similar to any other cluster endpoint that you would have seen with DocumentDB. Now, when I go back to the global cluster demo and select my secondary region 1, this is my cluster in Frankfurt region. So I'm selecting this. As you can see, it opens up in a new tab, automatically switches the region to Frankfurt, and it shows me the connectivity and security tab. And if you look at the cluster endpoint over here, this has a -RO. This indicates that this is a read-only cluster. Likewise, if I go back to my Ohio region, to my global cluster demo, and select my secondary region, if I click on this, it will open up another tab, which will automatically be switched to the Mumbai region. and it'll show me the connectivity and security tab and all the other tabs like any other cluster I can access here. And you can see that this was also a read-only cluster. So that is basically what I wanted to show in this demo about which was to create a global cluster and walk you through what those cluster endpoints look like. So we will come back to this cluster in a bit. For now, let's go back to the presentation and take a look at the use cases that global clusters can help you solve. All right, so the common use cases for global clusters are disaster recovery and data locality. Global clusters allows you to promote secondary clusters to primary for faster recovery in the event of a regional outage. And this makes it ideal for DR or disaster recovery use cases. You can also bring data closer to the users in different AWS regions to enable faster reads for globally distributed applications. So you can use global clusters for those data locality use cases and help with low read latencies. Let's dive deeper into these use cases now. DR or disaster recovery is a very common use case for global clusters. Since data is replicated in near real time, global clusters allow you to be up and running in a secondary AWS region in less than a minute's time, if and when a regional outage happens. There is no data movement that is required to happen when performing global failover, and the time taken for this recovery is just the time it takes to promote the secondary cluster to a standalone cluster. Also, use cases where you want to migrate data across regions are easily solved by global clusters. One of the important points to note here is the cluster topology, and I showed this to you while creating the cluster. Your primary cluster will be running the required number of instances. Like in our example, we had 3 instances to satisfy your application SLAs and availability target. Since replication is offloaded to the storage layer, the instance count for your DR cluster, right? Like in our case, in our Frankfurt region or Mumbai region, the instance count, I intentionally chose it to be 1 or 2, right? The key point is it need not match the primary region because of the replication happening in the storage layer. You can have a DR cluster with just 1 instance and still get the same low replica lag and high durability in the secondary region. Thus, offloading replication to storage helps with cost optimization in addition to this low replica lag. And scaling your secondary cluster will take about 8 to 10 minutes, regardless of the data volume, due to the decoupled compute and storage architecture that we talked about earlier. And since replication is offloaded to storage layer, there is little to no impact to your application performance as they typically interact with the compute layer. The low replica lag of less than a second enables you to use the secondary clusters to perform local reads, thus enabling you to build globally distributed applications that can read data from clusters that are closer to the end user, and thereby avoiding this cross-regional latencies, making, again, global clusters a good candidate for data locality use cases. Okay, I will now demonstrate both of these use cases. I'll start with the data locality use case and then show the disaster recovery use case. So let's go to our AWS DocumentDB console over here, and I'm going to be using this global clusters cluster demo global cluster, and I'll be first showing you how I can perform writes and reads to this cluster. So we have our primary cluster, which is in the Ohio region, and we have 2 secondary clusters in Frankfurt and Mumbai. So I'm going to bring up my EC2 instances now, and as you can see, I have 3 EC2 instances here. One is in the Ohio region, the other is in Frankfurt, the other is in Mumbai. So let me clear the screen here and let me connect to these instances. So I'm connecting to Ohio here, to Frankfurt here, and to Mumbai. All right, great. Let me clear the screen. And before I perform operations here, let me show you what this instances consist of, right? So think about these instances as the app server hosting a code, like application code, that talks to DocumentDB. So I have, in each of these instances, I have some Python applications, right? I have a sample app py, which I'll be using for the first demo. And this sample app py performs write operation in Ohio region, which is our primary cluster. So it connects to the DocumentDB cluster in Ohio region and performs write operations there. And this sample app py connects to the DocumentDB cluster in the Frankfurt region and performs read operations. And likewise, this sample app py connects to DocumentDB in Mumbai, which is a secondary region 2 cluster, and performs the read operation there as well. So this sample app py looks for an endpoint as an environment variable. So what I'm going to do now is I'm going to set an environment variable for each of these regions. So I'm going to come over here. I'm going to say export endpoint, and I'm going to set this to the primary cluster's cluster endpoint, because this endpoint variable is what my sample app py looks for when it connects to DocumentDB. So I'm going to do the exact same thing for the other 2 regions as well. I'm going to export the endpoint for my Frankfurt region, which is secondary region 1, and I'm going to export the endpoint for my Mumbai region, which is secondary region 2. Now that I have exported these endpoints, let's go ahead. Sorry about that. Let's go ahead and clear our screens. And I'm going to run the application. So I'm going to run sample app py. Again, this sample app is going to write in the primary region, and these 2 are going to be reading. So let's hit enter. And as you can see, this app wrote data, and all that I'm doing is inserting some simple 5 records, and I'm also logging a timestamp. And you can see that this data is retrieved in Frankfurt and Mumbai region. So if you look at the latency, this was written at 11 seconds and 06 milliseconds, and it was read here at 11 and 69. So that's about, it's about like 600 to 700 milliseconds. And here you can see that it is 1174. So that's about 700 to 800 milliseconds. So again, like I said, the latency is typically less than a second, and the data that I wrote into Ohio was read in Mumbai in less than a second latency. So that is our first use case, which is data locality. And now let me show you the next use case, which is disaster recovery. So let's say that our primary region, Ohio, is down for whatever reason, right? So, and in this case, what you want to do is you want to be able to use one of your secondary clusters, as a part of your business continuity plan. You want to be able to start using that cluster so that your applications are not down, right? So what do you do, right? So if primary region is down, you can use the secondary region. You can promote the secondary region to a new primary. So the steps that we recommend for this is, as a first step, you stop all your applications that are writing to the primary region. Obviously, that is down, so you don't want to be like writing to a region and lose those rights. So stop your application from writing to primary region 1. And then in a scenario like this, where you have 2 secondary regions, pick one of the regions that is ideal for your workload. And this is going to most of the times depend on which region will have low latency for your user base, right? Let's say your users are predominantly in the US. So obviously, routing them to Frankfurt would have a lower latency compared to routing them to Mumbai, right? So let's say that is our case. So I'm gonna, I want to be using this secondary region as a new primary since the primary region failed. So how I do that is select this region, go to actions, and say remove from global. So this is a one-step process which performs 2 different things. It removes the secondary region 1 from the global cluster called global cluster demo, and at the same time, it also promotes the secondary region 1 to a standalone cluster that can accept writes. So I'm going to click on this remove and promote, and this process is going to take about a minute's time to basically promote this secondary cluster. So it's going to first remove it from the global cluster demo, and then it's going to promote it to a standalone cluster, right? So if I click on this, it'll take me to the Frankfurt region, the EU Frankfurt region, and you can see that this cluster status is now in promoting. So basically, this secondary region 1 cluster is in the process of being promoted to a standalone primary cluster. And you can see that our connection string still has that hyphen arrow indicating that it is a read-only cluster. So like I said, this process will take typically less than a minute time. And when it completes, you can see that this hyphen arrow will no longer be in the cluster endpoint. And that will indicate that this cluster is now ready to be used as a standalone cluster. And you can then also, start from this cluster and create multiple. You can convert the secondary region 1 into a global cluster of its own, just like how I showed you before. You can add more regions to this cluster and make it a global cluster. So in about a minute's time, this cluster was promoted to a standalone cluster. And how I know that is you can see that the endpoint no longer has hyphen arrow, and the cluster status is now available. Now that we have promoted our cluster to a primary cluster, this cluster should be accepting writes. So what I'm going to do first is I'm going to connect to this cluster from the Mongo shell, and then I'll also show you how you can connect using the Python application similar to the one that we used before. So let's go back to our EC2 instance. And I'm going to paste the connection string, remove this password placeholder, and enter a password. So as you can see, I'm connected to the Frankfurt cluster, and the prompt shows me that I'm connected as primary. So let's go ahead and look at the databases here. So if I do show DBs, I get one database. So I'm going to use that database, and I'm going to say show collections. And it has one collection called test, which is basically, it has a collection called call under the test database, which is basically the collection that was written to from this primary region earlier in our previous demo. So I'm going to say db.call.find. And I'm just going to do a count of it. Oops, if I can spell count. I'm going to do a count. And now I know that I have 5 records, which was written from the primary region. So that is good. Right now, let me exit off the Mongo shell. And it is also important to know that the endpoint has now changed, right? So I'm going to export the new endpoint. Again, here, earlier when I did the export, it was the endpoint with -ro. So now I'm going to export the new endpoint without the -ro because this is no longer a read-only cluster. So I did that. And now if I do an ls, I have a new writer.py, which is going to perform writes on this cluster, on our secondary region 1 cluster. So let's go ahead and call that program. And as you can see, all that the new writer.py does is it added 5 more records. It inserted documents 6 through 10, and it did a full read of what is present in this collection. So it brought the data that we wrote earlier, the first 5 records, and the one after the disaster recovery scenario. So the point here is we did not have to move any data. Within a minute, this cluster, secondary region 1, was promoted to primary, and it allowed us to perform write operation into the cluster, and it also retained the data that was previously replicated from the older primary cluster. So that's how you would be implementing disaster recovery use cases. As a best practice, what we recommend is if you have multiple AWS regions like how we had 2 secondary AWS regions. So if you have multiple secondary regions, then remove all of them from the global cluster. Because in this scenario, let's say the primary is down, it's not going to be replicating data to the secondary regions, but the secondary regions are not down. So your applications can still read from those secondary regions. So to avoid any stale reads or reading older data because the data is no longer being replicated, to avoid those data consistency issues, it's a best practice to remove those older secondary secondary clusters from the global cluster. And like I mentioned earlier, right now we have this cluster in the Frankfurt region. We have our we have our global cluster demo, which is going to have the other two regions. But the main thing is here you have your secondary region 1. Now this is a standalone primary cluster, and you can always add more regions to it to convert this into a global cluster. So that is how you perform disaster recovery with global clusters. And with that, I want to say thank you for your time and attention. That brings us to the end of our today's session. And I can now address any open questions.